Hello, welcome back to Chemistry in Action. In our earlier episodes, we came across many kinds of solids, liquids, and gases. In other words, the phases of matter. Today, we will take a longer look at these phases of matter. So, keep tuned to your program, and we will return after a short break. Look around us. Our environment has three physical components. One in the solid phase, the other as liquid, and the third as gas. The ground that people live on and build their homes is called the lithosphere. The lithosphere is a solid outer layer of Earth made up of a continuous layer of rocks about 100 kilometers thick. This river is part of what is called the hydrosphere. The hydrosphere also includes seas, oceans, lakes, streams, glaciers, groundwater, and all other natural bodies of water. The hydrosphere covers about 75% of the Earth's surface. The air around us and the gases that envelope the Earth make up the atmosphere. The atmosphere reaches up to about 500 kilometers above the Earth's surface, but 99% of the mass of the atmosphere is found in the first 30 kilometers or so above the surface of the Earth. These solid, liquid, and gaseous components of our environment serve as our life support systems, and studies show that life on Earth thrives best where these three phases of matter interface or meet in places like this. A plant like sugarcane absorbs water through its roots. The soil solution provides the plant the other nutrients it needs. During daytime, sugarcane absorbs carbon dioxide in the air and releases oxygen. The carbon dioxide is needed for photosynthesis. At nighttime, the plant absorbs oxygen from the air for its respiration and releases carbon dioxide. If water were not liquid, could it easily be absorbed by the plant roots from the soil and rise up the stem? If carbon dioxide and oxygen were not gases, could they pass through the stomata of the leaves? If soil were not solid, could it support trees and other plants? How we use things around us depends much on their being solid, liquid, or gas. What are the properties that distinguish each phase? In some restaurants, we sometimes find ice statues used as table centerpieces. Ice sculptors meticulously chisel the ice blocks to the shapes they want. A solid has rigid shape and volume. In the case of ice, it will maintain its rigid shape and volume as long as it stays frozen. But once it melts or turns liquid, it loses its shape. Its volume also changes because its density in its solid phase differs from its density in its liquid phase. Ice floats on water. This shows that ice is less dense than water. When it comes to this property, water is unique. It is the only substance which is less dense in its solid phase than in its liquid phase. All other substances have the opposite property. They are more dense as solids rather than as liquids for the same volume. This unique property of water is very important in supporting life and the environment. Protected from the cold by a layer of ice that floats rather than sinks in water, life thrives in lakes and oceans even during the winter. Solids are usually hard, but different solids vary in hardness. There are soft solids like lead and hard, heavy ones like iron. Some are brittle and crumble under mere pressure from our fingers. There are small, grainy solids like sand. Others are malleable like steel. Many of our farm implements and industrial equipment are made of steel. Liquids can easily be poured. They take the shape of whatever container they are in, but retain their volume before and after pouring. Liquids also flow just like rivers or streams. Being fluid or liquid, a soil solution is easily absorbed by plant roots and rises up the stem into the other parts of the plant. Our body cannot absorb and use the nutrients in our food unless these nutrients are in liquid solution. Some chemical reactions take place faster in the liquid state rather than in the solid state. The liquid and solid phases are called the condensed phases of matter. This is because matter in these phases occupies relatively smaller volumes than in the gaseous phase. We can easily observe and identify these condensed phases. A gas, like the air around the solid and liquid you see, cannot be absorbed as easily unless it is colored. But we can infer its presence in other ways. Arceli da Silva has here 2 empty dry bottles. She fills bottle A with tap water and bottle B with cracked ice. She then covers each bottle tightly and wipes the outside wall dry. Observe what happens. Droplets of water form on the outside wall of bottle B. We find no such droplets on bottle A. Where did all these water droplets come from? Could they have come from inside the bottle? Not at all, since the bottle is tightly covered. They could have come only from the outside. These droplets used to be part of the water vapor in the air outside the bottle, but they condensed or turned from gas to liquid due to the low temperature of the bottle. In the case of bottle A, the temperature of its wall is not low enough to condense any water vapor surrounding it. Vapor is any substance in its gas phase that exists either as a liquid or solid at room temperature, as in water vapor or alcohol vapor. We use the term gas for substances that exist